Imagine waking up one morning in 2032 to breaking news: an asteroid has just slammed into the moon, carving out a massive crater, blasting dust into space, and sending shockwaves through the scientific world. While Earth itself is safe, satellites and astronauts in lunar orbit suddenly find themselves at risk. This isn't science fiction, it's a real scenario astronomers are keeping an eye on right now. Discovered only recently, this asteroid has captured global attention because of a surprising detail. While it poses no threat to Earth, current models suggest it carries a 4% chance of striking the Moon in the year 2032. That may sound tiny, but in planetary defense terms, 4% is enough to spark serious discussion. Why? Because if it does hit, the consequences won't just be written on the lunar surface, they could ripple all the way back to Earth. In this video, we'll break down what makes 2024 YR4 so interesting, what would happen if it really slammed into the Moon, and how humanity might respond if we confirm it's on a collision course. When astronomers first spotted 2024 YR4, they had limited data. The asteroid's orbit wasn't yet pinned down, and early models suggested a 3% chance of striking Earth itself. For context, that's astronomically high. Most asteroids are dismissed as harmless within days of being discovered. Thankfully, with more observations, scientists quickly ruled out any Earth impact. Our planet was never in real danger. But then the focus shifted. The updated orbital models revealed something surprising: the Moon could be in the asteroid's path. Right now, the probability sits at just over 4%. That's not a guaranteed hit, but it's significant enough that scientists are paying very close attention. And the story doesn't end there. More observations planned for 2028 will give us a much sharper picture. Those measurements could either rule out the threat entirely, or raise the alarm even higher. So, let's imagine the scenario. What if 2024 YR4 really does slam into the Moon in 2032? Astronomers estimate its size between 53 and 67 meters across, about the same size as the object believed to have caused the Tunguska explosion in Siberia in 1908, which flattened over 2,000 square kilometers of forest. On Earth, that would be catastrophic. On the Moon, things play out differently. A strike of this size would excavate a crater roughly a kilometer wide, releasing energy equivalent to several megatons of TNT. The Moon, of course, has no atmosphere to cushion the blow or burn up incoming fragments, so the impact would be raw and violent. But here's the twist: the biggest concern isn't the crater itself. The Moon has been bombarded countless times throughout history, it can handle another scar. The real issue is ejecta. Even tiny particles can punch holes in spacecraft walls or fry sensitive electronics. A micrometeoroid storm could put communications, navigation, weather satellites, and even the International Space Station at risk. By the 2030s, with NASA, ESA, China, and private companies planning permanent lunar bases and orbital platforms, the stakes are higher than ever. Another method is the gravity tractor approach, where a spacecraft hovers near the asteroid, using its own gravity to slowly tug the rock onto a new trajectory. But here's the catch: we don't know YR4's exact mass or composition. While its size estimate is solid, its density is a mystery. It could be a solid block of rock, or a loose rubble pile held together by gravity. If we guess wrong, a deflection mission might fail, or worse, alter its orbit in unpredictable ways. That's why many experts argue for a reconnaissance mission. Sending a probe to fly close to YR4 before 2028 could give us critical data about its mass, spin, and structure. The problem is timing. We'd only have about 4 years between 2028 and 2032 to act. That's tight, but possible if treated as a global priority. If deflection proves impossible, the next option is outright destruction. The goal here is to break the asteroid into smaller fragments so they can't cause serious damage. Kinetic disruption, hitting the asteroid with a heavy impactor at extremely high speed to shatter it. Nuclear disruption, the most controversial idea. A standoff nuclear blast near the asteroid could vaporize part of its surface, completely disrupting it regardless of its composition. Treaties currently ban nuclear weapons in space, but if a lunar impact threatens astronauts, satellites, and billions of dollars in infrastructure, those rules might be reconsidered. Satellite safety, a micrometeoroid storm could damage or destroy satellites, costing billions and disrupting everything from GPS to weather forecasting. Astronaut safety. By the 2030s, multiple lunar missions will be underway. A sudden impact event could endanger lives directly or indirectly. Scientific opportunity. Watching a modern lunar impact of this scale would give astronomers an unprecedented chance to study crater formation in real time, improving models of how impacts shape planets and moons. Planetary defense. Perhaps most importantly, this is a rehearsal. 2024 YR4 is just one of thousands of near-Earth objects crossing our orbit. Many are much larger and could pose real danger to Earth in the future. The strategies debated today for YR4, reconnaissance, deflection, disruption, will be the same ones we use when the next, truly dangerous rock comes our way. For the first time in history, humanity isn't just a passive target for cosmic events. We now have the tools to protect ourselves. The question is, will we act? Asteroid 2024 YR4 may never hit the moon. In fact, the most likely scenario is that it passes harmlessly by, becoming just another name in the long catalogue of near-Earth objects. But the 4% chance is enough to remind us that we live in a cosmic shooting gallery, and that preparation matters. By 2028, astronomers will know much more about YR4's true path. If it's headed toward the moon, humanity will face a critical test. Can we come together to prevent a cosmic event before it happens? Earth itself may not be at risk this time, but the lessons we learn could one day save our planet. Because the next asteroid might not just aim for the moon. Kindly like, share and subscribe. Thank you for watching my channel.